Hello, welcome to our little corner on the web, where we hope to develop and nurture a love for math. Today, we will go over the 27th PMO Qualifying Stage, Part 3, Question 2. Okay. Question 2 asks, suppose that x sub 1 is a point on side BC of triangle ABC such that the angle AX1C is equal to 120 degrees. Moreover, suppose that y1 is the point on side AC such that angle x1 y1c is 120 degrees. Define the sequences of points x sub I from I equals 1 to infinity and y sub I from 1 to infinity such that x sub I is on side BC and yi is on side AC where the angle y1 or yi xi plus 1 c is equal to the angle x sub I y sub I c equals 120 degrees for all I, which are elements of natural numbers. If x sub 1 a, the ratio of x sub 1a to x sub 1b to x sub 1c is equal to 1:3:1, and a y sub 6 is equal to 728 over 81, then the length of AB can be written in the form a squared of b, where a and b are positive integers and b is square free. What is a plus b? Okay, for those who want to try, you may pause here and give the question a try before proceeding further and looking at one proposed solution. Okay. Okay. Diving into one possible solution. Okay, first things first with these types of problems, we want to be able to draw the figure. So we're given the ratios and the angle, so we can actually draw this one quite easily. So if that's BC, we know that it's divided into basically 4, and the angle is 120 going to A, so it's somewhere there. Okay, and so we got some shape like that. Okay, so we know this is 120 degrees. We know the ratio is 1:3:1, so this is x, some x, this is some 3x, and this is some x. Okay, so we're going to be asked for AB later, so we need to find an expression for AB. For that, we'll use cosine law. So AB squared is equal to x squared plus 9x squared minus 2 times 3x squared cosine of 60 degrees. Basically, this is from, I'm just going to name, this is x sub 1 here. So this is basically from triangle A, x sub 1, B. Okay, let me get that. Okay, so AB squared, the cosine 60 basically cancels the 2, that's 1/2. So 1/2 and the 2 cancels. So this is just equal to 7x squared. Okay, therefore AB is some square root of 7x. Okay. Maybe I should have used a different variable, but that's okay. Okay, and then we now want to drop our, or find AC first, actually. So notice that if I drop this perpendicular here, because it's an isosceles triangle, we actually end up with a 30, 60, 90 triangle, okay, where this is 30 and this is a right angle. So remember, the 30, 60, 90 triangle, the ratio of the sides is 1:√3 is to 2. Okay, so right now the 2 is the x, so this basically means that a to y1 is √3x over 2, and so AC is, well, I'll write it here, AC is √3x. Okay, because each side here is root 3 over 2 x. Okay. So let's use different color. We'll get confused quite easily. So oops, that's not y1 actually. I already got confused myself. That's just the foot of the perpendicular. So y1 we're given is forming a 120 degrees at y1. So x1 y1c is 120 degrees. Okay, so that's forming 120 degrees. So it's a similar triangle to triangle AX1C. It's actually similar to triangle X1 Y1C. And the ratio of the sides is basically root 3. Okay. This means that Y1C is root x over root 3. Okay, so if that's not clear to you, the sides on AX1C is basically x is to x is to root 3x. Okay, so the longest side is root 3x, or the base of the isosceles is root 3x. Here, the base, the first one is from AX1C triangle from x1 y1c. The base is x, so that means everything is divided by root 3. So this is x over root 3 is to x over root 3 is to x. That's how we got y1c is x root 3. Okay, and we're told to repeatedly do it. And what you'll notice if we repeatedly do it is the next one is also an isosceles triangle, also 120, 30, 30. Meaning if we draw the green from y1 x2c, okay, y1 x2c is also 120 degrees. So now it's also similar. But now the base of the isosceles is x root 3, right? And as it was a while ago, we divide everything by root 3. That's the ratio of the similar triangles. So that's basically x over 3. So we know that x2c is x over 3. And then we repeat it again one more time. Or a few more times. Okay. Now, the base is x over 3. So y sub 2 of c is x all over 3 root 3. And if you follow this, we just keep dividing by root 3 as we bounce from y sub 2c to x sub 3c, and so on and so forth. So every time we hit the next y, we're dividing by 3. So if you just follow that, then that means y6c is no more than x all over 3 to the 5th times root 3. Okay. So now we can find, now we can compare that to a y sub 6. Okay. Okay, hopefully we can fit it here. AY sub 6, we know is 728 over 81. And this is equal to basically AC minus Y sub 6 of C, which is equal to, well, AC is no more than what we have here, root 3x minus y sub 6 of c, which is what we have there, x all over 3 to the 5th root 3. Okay. Simplifying a bit, we put both in the denominator of 3 to the 5th root 3. We have x times 3 to the 6th minus 1 all over 3 to the 5th root 3. Notice the 3 to the 6th minus 1 is basically 728. Okay, so maybe I'll delete some stuff here on the right so that we have some space to write. So if you notice that that's just 728, those two things cancel, right? Those two things cancel, and we basically have 3 to the 5th root 3 over 81, which is 3 to the 4th, is equals to x. Okay, so x is basically equal to 3 root 3. Note that AB, since AB is equal to root 7x, then AB, which is root 7x, is no more than root 7 times root 3 times 3, or 3 root 21. So we're looking for the form a root b, so we have it, and we want a plus b, so it's just basically 3 plus 21, which is 24. Hopefully this solution was helpful and educational. If it is, do hit the like button and subscribe. Thank you for watching.